Good morning, 3rd and 4th grade. Today we're going to read the next section of our science book, Chapter 5, Part Air, Wind, Moving Air. And we've been looking at wind and air for quite some time, and we've learned several different things about air. First of all, we've seen where air is. We've seen that it's a gas. Gases are in air, so we've seen what it's made up of. We've also seen that there are layers of air and where air is generally found. Then we also learned that air has weight. In addition to that, it has pressure, and that air pressure changes. We've read about that. Now today, we're going to look at the temperature that we have with our air. So let's start reading. We have a verse from Ecclesiastes 1:6 to read first. The wind goeth toward the south, and turneth about unto the north. It rolleth about continually, and the wind returneth again according to his circuits. So air has temperature. Have you ever noticed that the earth and water become warmer during the day than the air surrounding us? Since the atmosphere is closer to the sun, it seems as though the air should receive heat from the sun first. However, this does not happen. The sun heats the earth and water directly, but warms the air very little. And you might wonder, well, why is this? Well, it's because air is clear or transparent. That's going to be an important word later on. Things that are transparent allow light to pass straight through to the other side. So think of things that are clear, like plastic containers. They allow light to pass straight through. Very little of the light's energy is absorbed by transparent object. Heat and light from the sun pass straight through the air to the earth and water, and they get warmed up first. The earth and water absorbs the sun's energy and are heated. But we know the air has warmth, at least some warmth. So how is air heated? You will remember that the molecules of matter are always moving. Now, some of them are moving faster than others, but they're always moving. Molecules of gases move faster than molecules of solids or liquids. Molecules in the air move very rapidly. They bump into the earth, and some of the heat passes from the molecules of the earth to the molecules in the air. And we can see that here. As the molecules are constantly moving, the molecules in the air are constantly moving, they bump down into the earth, they absorb some of that heat, or some of that heat passes from the earth to the air. Temperature and pressure cause wind. So we've seen that air has temperature, and in our last section we saw that air has pressure. And the combination of this pressure and this temperature cause wind. So let's read about that now. Because the earth is tilted, the surface of the earth is not heated evenly by the sun. And we've seen that, how we've got our axis and the earth is tilted, so it's not straight up and down, it's tilted slightly. The part of the earth tilted toward the sun receives the most heat. The air above this part of the earth becomes warmer than the air in other places. And that just generally makes sense because it's getting more of the sun's energy, the sun's rays. When air is heated, its molecules spread out. So the air gets heated and it expands or spreads out. As warm air expands, it becomes less dense than cool air. Warm air rises because it is less dense. So you think about if you've ever been to an indoor water park, and before you've gotten all wet, if you go up to the very top to go down one of the big slides, it usually feels really, really warm up there and really, really moist. And that's because this warm air is rising. When warm air rises, it leaves an area of low pressure near the Earth's surface. So as the warm air rises up away from the Earth, it's leaving an area of low pressure down near the Earth. Cooler, denser air flows into the low pressure spot to replace the warm air that rose. As air continually heats and rises, cooler air continually flows in to take the place left by warmed air. This constant motion of the air is what causes wind. And let's see this importance of wind. There are many things we enjoy doing which would be impossible without the wind. Can you imagine trying to fly a kite or sail a boat without the wind? It would be pretty much impossible to do so. But if the wind stopped blowing, the effects would be far more serious than not being able to just fly a kite. If the air did not circulate or move around, the hot parts of the earth would become hotter and hotter until no one could bear to live there. The cold places of the earth would become colder and colder. Because air does circulate, winds flow around the earth and help to even out the earth's temperature, keeping the north and south poles from becoming really, 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 really cold beyond what they already are cold, and keeping the area around the equator from getting way too warm. The wind performs many useful jobs. Some plants depend on the wind to pollinate them. If you think about dandelions, they depend on the wind to blow them, or people to blow them around, their seeds to blow around, and there's several other plants that depend on that as well. The wind lets us know of changing weather. In some parts of the world, warm, dry winds form over mountain ranges. These winds are sometimes called snow eaters because they evaporate snow. These winds help to prevent the flooding which would occur if all the snow melted in the usual way and ran down the mountainsides. Although wind is beneficial in many ways, it can also do damage. Windstorms such as tornadoes and hurricanes can do massive damage in a short time. And I think back to last summer when we had the huge storms that came through, and we saw many trees go down. There was a lot of damage from that windstorm. Winds also spread forest fires and cause sandstorms and soil erosion. And remember, erosion is the wearing away of soil by wind or water. Since air is not as dense as water, the wind cannot carry away large pieces of earth as quickly as water can. But over a period of time, erosion by wind can cause great damage to the soil. The wind's energy can be used to do work for man. If you have ever hung out wet clothes on a windy day, you have used the wind to help dry the clothes. Long ago, men used the wind's energy to sail large ships across the ocean. Today, people still enjoy sailing for pleasure. Several hundred years ago, people discovered that windmills could use the wind's energy to provide power for machines. A windmill works when a wheel driven by a wind turns a shaft. The shaft is connected to a machine that does the work. Since the wind does not always blow at a constant speed, windmills cannot be used if steady supply of power is needed. Windmills are used today in some places to grind grain, to pump water into storage tanks, and to generate electrical power. And once again, unless you can guarantee that you're going to have a constant steady stream of wind, we can't use them for things that would need constant, like electricity. But we can generate electrical power. We just can't depend on them to constantly be running it. As we turn the page, there's just something to do. The power of moving air. To observe the energy of moving air, try the following demonstration. You will need a jointed plastic straw like this. So we need a straw that's got the bendy part here. And it says a table tennis ball, and that's the idea of a ping pong ball. It says bend the straw into an L shape with the short end straight up. So I'm going to pull out my jointed straw here and bend it so my short end is pointing up. Place the long end in your mouth. Begin blowing a steady stream of air and gently place the table tennis ball just above the short end. So I would start blowing in this end of the straw and then gently get the ping pong ball held up above the short end here. It says, what happens to the ball? So what do you think is going to happen to the ball? I'll demonstrate this in a moment, but I want you to make some guesses. What do you think is going to happen to the ball? We'll find out. Moving air beneath the ball has raised the ball up in the air. The ball will remain in place as long as you continue to blow steadily, and that's the important part of this. Eventually, your lungs will run out of air and you won't be able to continue blowing because the molecules of air around it are moving quickly. And so I'm going to demonstrate this in a moment, but it's similar to back last fall when we had the science people with us and they had the leaf blower. And they were using that to keep the balls up in the air. It's a similar property or principle to that. Now, one other thing I want to point out is that this ping pong ball, it's kind of squished here. You can see that. So it's not going to work perfectly, but it should work at least a little bit. So let's go ahead and see if I can demonstrate that now. All right, 3rd and 4th grade, we're going to see if we can get this something to do from our science book to work. So I've got my jointed straw and I've bent it so the short end is up. And then I've got my table tennis ball. I like to call them a ping pong ball. And we're going to see if we can make this work. And as I said, it's got a dent in it that I showed you guys earlier, which makes it kind of tricky to do. But I did practice it and try it, and it sort of works. So put the straw in your mouth, and then I need to blow a steady stream of air while trying to get the ping pong ball to float up above the straw. So let's go ahead and give this a try. that try didn't work too well, I'm going to give it one more try. If you've got a straw and a ping pong ball at home, you can try it. It might work better without a squished one, but we're going to see one more time if I can get this to actually go. That time actually worked a little bit better than the first time did. So you can see, because I was blowing a steady stream of air into the straw, that allowed this ping pong ball to be able to float above it. And this is the energy that we have from the air that's moving. Have a great rest of your day.